Yeah.
I like that. All right, let's see which one.
14.
The one about braking distances.
Yeah.
Oh, okay, good. All right.
What section is it?
This is from the old book, so let me put this up here. The old book is about to just turn into dust. All right. How many cars are in the subject? So, how many cars? How many cars need to be tested to be within 2 feet?
What section is that?
Section 7.3. Cars need to be tested to be within 2 feet of the mean braking distance That's what it says, right? Sigma 7. Yeah, cool. All right. Oh, sorry. What confidence level do you want?
99.
All right. So I think they tell us that it's normal to begin with, so we don't have to worry about that part. What kind of formula do I need to use here? What's the unknown? What's the variable that I don't know that I want to figure out? N. I want to figure out N. So do we have a formula that N equals something? Yes. And which one do I want to use? The one with a P hat, Q hat in it?
No.
Probably not. There's no percentages in there. It's a good giveaway. So I want to use the other one. Because they give me standard deviation, right? So the formula, what is the formula for that sample size formula?
N equals Z squared, standard deviation squared, divided by E squared.
Kick ass.
Yes,
I mean, good. So, what do I not know? What do I know? Let's start there. What do I know that I need here? I know the standard deviation. Tell me that directly. How much is E? Yeah, I want to be within. Now see how that is a very... Now look, see how I started talking really slow? That is a key word for these problems. It's a magic word, within. I want to be within. Whatever follows will be the error. Now, they might not use the word within all the time, but that idea. I want to be at this close. I want to be within. I'm going to be off by. That tells you what the error is. Right? I always get people that can't figure out what that E is going to be. It's going to be how much you want to be off by. I want to be off by 2 feet. So E is 2. Sigma 7. For 99% confidence, what's Z going to be? You can look at your T-score chart now, right?
2.576.
Beautiful. Good. 2. And now it's just plug and chug. All right. So the first thing I had to realize was they're asking for how big of a sample do they need to take. So that kind of makes it obvious. I want N equals something. I got to figure what N is. And then I just got to write the formula down and figure out, well, how do I figure out what I don't know? I know this, I know that. I got to figure Z out. Easy. Cool. And so, what do you get when you plug that in there?
2.576 squared times 7 squared over 2 squared, 4, whatever. I don't know what it is.
270, like 80.
49.
81.25. So what's the actual answer? Sweet. Whatever you get there, you round up no matter what. If you need at least 81.25 cars, you're not going to say, okay, your car is the quarter car. Sorry. No, that's mine. Don't do that to my car. So if you need at least as many cars, you go up to 82. If you go down to 81, did you get at least 81.25? No. So that's why you always round end up. And it's all kind of tying into the whole thing about being more conservative. I need that. I'm going to go up to be more conservative. How's that? Is that cool? Yes?
Number 31 and
just gotta love the title of this problem: Tattooed Democrats.
That's what you gotta watch out for.
Yeah, exactly. I'm a Democrat, and I have a tattoo. I'm not afraid to use it. Has everybody got what they want from here? I'll take that as yes. Let's see. So this one says, this sounds very familiar. Find the sample size needed to estimate the percentage of Democrats who have tattoos. So they say use a 0.05 margin of error.
Find the sample size needed for what?
Sorry. Sample size needed to estimate the percentage of Democrats who have tattoos. Use a confidence level of 99%. Did I just say the same thing? 99%. And use results from a prior Harris poll suggesting that 15% of Democrats have tattoos. So what is 15%? What do I set? What value is that for? What P? Yeah, beautiful. That's P hat. So P hat is 0.15. So Q hat is 0.85. Is that cool? If they didn't tell me that, if I didn't have some prior study to go off of, what would I use for P hat and Q hat? 0.5, and then the product is 0.25. I like it. Cool. All right, do you guys remember that? If I don't know, my best guess is 50%. That's my best guess.
The 0.15 was given in the problem?
Yes.
Okay.
Exactly. Yes, sir.
So if they didn't give you the 15%, it would
You would
just
use
50?
50 and 50, yeah.
Okay.
0.5, 0.5. Cool. And again, that's why the formula for that has a 0.25 there, right? Because the general formula is z squared p hat q hat e squared. So if they were both 0.5, the product would be 0.25. Cool. I just hate that they make it look like it's a whole new formula. No, it's the same damn thing. So now you just plug and chug again, right? This is nice. What's the z-score for 99%?
2.576.
Yeah, we just looked that one up. So just throw that in there, throw these in there, and then the error, they want me to be within 0.05. The biggest mistake I see is if they say you want to be within 5%, people put a 5 there. 5% is 0.05, right? The percentage is something humans made up. The 0.05 is what the number really is, right? So be careful about that. You start getting N, you need to talk to 0.07 people. Like, what? Just talk to nobody, you know it. I know it. No, it's not good. All right, so then whatever that gives when you put that numbers in. All right? Let these problems, it's important to understand the concept. I would never teach this like this, but once you understand the concept, it really is just collect what you need from what they tell you and throw it into the right place. Okay, good, you good? Yeah.
Can you read the old book number 26 of 7.2?
Can I borrow that, Kelsey?
What?
Your book? Can I borrow?
No, what section?
7.2?
Yeah.
Number who?
26.
36?
26.
26, okay. All right, so, look at all you guys. It's funny, man. There's a theme going on today. So 26 says, use the given data to find the minimum sample size required to estimate a population proportion or percentage. So 26 says, what do you think the confidence level they want is?
99.
99 is crazy, man. That's today. So confidence level, 99% confidence. They want a margin of error of 0.005. So they want to be within 0.5%. Probably going to have to talk to a lot of freaking people. And P hat and Q hat are unknown. So it's the same formula we had here, right? So now what do you put in for P hat and Q hat? The 50-50. For 99%, what's the z-score?
2.576.
That's crazy, man. 0.5, 0.5, all over the error, which is 0.005 squared. The other big mistake is people forget to square certain things, or you square too much. The 0.5s are not squared, right?
Wait,
Just
they're
be
not?
careful when you plug and shot. So, whatever the hell you get there.
Feed.
66,000.
58.
Yeah, so you got like 57 point something?
Yeah.
Okay.
Oh.
Which makes sense. If you want to be within 0.5% of correct, you're going to have to talk to a lot of freaking people. Gallup talks to 1,200, 2,000 people somewhere in there all the time, and they're always off by 4%. Their error is always plus or minus 4%. You want to be within 0.5%. Damn. You're going to have to talk to a lot of people. Now, I want you to note something about this problem. You have no idea anything about this problem. Is it talking about the percentage of people who smoke? Is it talking about the percentage of people who cheat on stats tests? Is it talking about the percentage of people who whatever? I have no idea. All I know is somebody wants to be within 0.5% at 99% confidence. Those two together make this number huge. If they want to be off by more, if they were okay with being off by more, or if they were okay with being a little less confident, that number would come down. But both of those kind of push that number way up. Okay, maybe. All right. Okay. Anything else from homework? Did I give you back? No. Cool. All right, let's get back into... Let's do one example from what we did last time. And then we're going to devote the rest of the day to chapter 8. So, oh, I don't want that. Oh yeah, I do it. I always do. Okay. So you have to excuse me. I'm not feeling very creative. So those numbers can be whatever you like them to. An average of 11.29 what? Who's got a good creative spark today? Anybody? Does it always have to be me, does it? Sure. How many pretzels they currently have in their pocket? Certainly. I have, didn't know I had pretzels in my pocket. That's so weird, man. Are you David Blaine? No, you have pretzels in your pocket. Check your pocket. Alright, so we find... alright, this makes a little more sense. So we'll say... I like the pretzels. Well, we'll say maybe that's how much money they have currently in their pocket. Huh?
To buy pretzels.
To buy pretzels, exactly. Yeah, I like it. So we wanna find the. Let's not do 99%. All right. We're gonna find the 90% confidence interval for the true. Make it a letter, Jeff. The true mean amount of money in people's pockets.
To buy pretzels.
To buy pretzels, right? Because they actually have $248 in there, but they've got that set aside for their premium pretzels. All right, so a couple things here. What has to be true at the beginning to even worry about doing anything?
Normal.
It has to be normal. How do I? What is it about this? Did I tell you it was normal?
No.
Beautiful. The sample size. So one normal. Check. N is 217, which is greater than 30. Central limit there. Good old central limit there. Now the second step is what? Related. Yeah, sigma or S, because that's going to tell me, do I use T or Z? Right? Now, if you weren't here yesterday, you're like, okay, you know, yesterday in terms of class. Thank you, smart ass. Yeah. So if you weren't here the last time, that didn't really make any sense what I just said, but last time we introduced something called T-scores. So the idea behind T-scores are, if there's something you don't know, especially they were created for when I don't know sigma. I only know S. So if I took a decent sample, I know that the standard deviation should be close to sigma, but I have no idea what it really is. So to cover my ass for that, I use T-scores, which will always be a little bit bigger than the Z-scores. So that whatever confidence interval I create will be always a little bit bigger than the Z-score would have been. The Z-score interval would have been, right? That's part of covering my ass for not knowing something about the problem. You guys kind of with me? All right, so I know everybody who was here the other day is semi with me. So here, is it T or Z?
T.
Definitely T because...
It's an S.
Yeah, we know S.
Population, I mean sample.
Not sigma. Okay, cool. So I gave us a weird sample size on purpose, just to remind you guys what to do in a situation when you can't find the degrees of freedom. So what's the degrees of freedom for this problem? 217 minus 1 is 216. That's the official degrees of freedom. So you guys voted?
No.
Well, that's one way to express your feelings. Do not vote. This is your priority.
Did you vote?
I like to get the little sticker. I wish they gave out shirts. That would be awesome. Yeah, of course they did. Yeah. It's the first time I voted in that new neighborhood. That was just so exciting. Can't even tell you. Let's see. So we got
2.601.
this guy here. Can you guys see that? Probably not so well. Everybody should have this chart now, right? Okay, that was an interesting reaction.
Yes.
Especially like,
Aliens.
oh, somebody turned my lamp off.
Wow, that's rude. Seriously.
There it is. Yeah, hold on. Where'd they put them? Where'd they put them? There we go. So if you look here, what's my confidence level?
90, not 99, because I'm,
Yes.
according to a couple of students, a retard.
Oh, okay. Don't listen to them. So we want 90% confidence. So if you make a 90% confidence interval, how much is outside? How much is in the tails that makes?
10%.
10%. So see how this is set up? The two tails. There would be 10% in two tails. There would be how much in one?
5%.
5%. So no matter which way you look at it, you're in the right column. So I want 10% in two tails to make 90% in the middle. And I go all the way down until I get to 216. But is 216 on there?
No.
So you always, no matter what, go to the next one down. No, not down, but down as far as numbers. So from 216, you're going to look at 200.
200.
To be more conservative. The whole theme of the day here is being conservative. So if we go up to 300, my t-score would be smaller than it would if it went the other way. That would be less conservative. So I just want to be a little more conservative. So I'm in this column. I go all the way down to
200.
200.
1.653.
1.653. And the beautiful thing about this whole process is once you get used to that chart, which is a lot easier than the z-score chart, really. Once you get used to the chart, all the work is the same, right? It's the formula is almost the same. So if you have a T there and an S there, And again, that kicks ass because the formula is telling you, hey, use a T when you got S. Right? So if you forget, just look at the formula. That's insane. So then I just fill it in. Again, this is more plug and chug. What's X bar? 11.29. T, we just figured out, was 1.653. Awesome memory. S, 3.82. Square root of N, 217. Don't put 216. That's degrees of freedom. I want N. N is 217. So if you do this
Get the
error in the calculator. First, I always suggest that you do this part here first. And then you're just going to add it to this and subtract it from this. All right, so you guys help me out. What do you get for that error? So I want to do this part first. This is the error. This much, give or take that. All right, so math people are really creative. We call that the error. So much you multiply.
So 10.
All right, what do you get?
10.86 maybe? 86.
For the error? For the
For
error.
the error, it's 0.428.
So about 0.43, right? Roughly?
Yeah.
Cool. And then you should get two outcomes here because it's got to be the interval between something and something else. So if you do 11.29 minus this,
Uh,
10.86. And if you do plus,
11.72.
good, 11.72. So that's the quick answer. That's the interval. Looks very much like interval notation from algebra. Oh, shit. Or not, if you don't want to think about it like that. It's just,
There you go.
what's the statement that you must give me? Yeah, we are
90%
90% confident.
that the interval
You always bring the units back in here for sure. You want to make this real physical, understand what's going on in the real world is that the interval $10.86 to $11.72 contains true mean amount of money in pockets. Not even people, they're just pockets just laying around. But don't just, you got to give me some interpretation of what it is in the real world, what's going on.
Do we ever round the degrees of freedom up? So, like, we had 216. If it was like, I don't know, like 266, whatever.
If it was like 290 or something,
Would that be 300?
maybe you could round it up.
Okay.
Yeah.
Better than that.
But I mean, in general, you're going to round down almost no matter what. I mean, you can see how little it's changing towards the bottom, right? In fact, over here, it becomes the z-score at 1,000, right? It's changing a lot at the top. In fact, if you had a really small sample, you could have to use 63, right? I mean, that's basically telling you, dude, why even? All right, maybe go talk to one more person, right? If you talk to one more person, all of a sudden it's 9. It's 1/7 the size. Holy crap! All right, you can find one more person to talk to. Yeah.
Does the first part of the phrase have to be exact? Because the book contains, I want to put capture. Most of the time my
Oh,
brain
that's
says
fine.
capture stuff.
That's fine. Captures, I love it because that's like the fishnet thing going out. I like it. So you can play on that. You can have your own, but just be careful with the semantics. If you say we're 90% confident that the true mean is in here, semantically, that's just wrong. It's not the right thing. That makes it sound like the mean is bopping around. It's not the mean bopping. It's our confidence interval. So we're 90% confident that this interval catches the mean. So if you made another interval, you'd be 90% confident that your interval captured the mean, right? Okay, and that's not a huge point, but it is a point. All right, how do you feel about all that? Looking up t-scores, putting it together into the confidence interval formula.
Ready to take a quiz.
Try to stay that way for a while. I love that. I love that. I understand it now.
It's gonna
All right.
have dreams about the
Continue
quiz.
understanding it.
Wake up thinking about the quiz.
All right. So that the sheet I gave out last time with the T-score practice on one side. Please tell me I brought some for myself. Yes.
With the red in the back?
Yeah. So this guy with the red writing.
Dun, dun, dun.
Red writing.
Blood.
Okay. So what I'm going to do is, let's see. We're going to do a slightly, well, maybe we'll do this example. Oh, it's just a little bit easier to, okay. So that's 2. What's up? Oh, the T chart. Okay. David, you need one? Anybody else need one of those? It's got 2 sides to it. Everybody's got that? Oh. All right, nobody else can have one because that's mine. All right. Oh, there's one. Okay, one more person can have one. Okay. All right. It's the easiest way to explain this kind of problem is to actually just jump into it. So that's what I'm going to do. Thank you. Yeah, now I got too many. Now I'm going to put that on. All right. So. So yesterday was a. Let's see if I want to come into this. Yesterday we had the voting thing. I don't want to go from that way. So if this is kind of a mean example, I don't want to do that.
Just do it.
Do it. So a friend of mine, she was from Italy. She came over and she was just amazed at how large Americans are. Large, yes. Huh?
Tall or
No,
Size.
yeah, yes, in size.
Obese.
Most other countries, of course, are a little bit smaller than us in general. Because Americans, we just love our sugar and processed stuff and everything. And I'm certainly part of that. So, so if we're, she's on the plate, right? And somebody's next to her is like, I have this claim, at least half of Americans are overweight, right? And they're like, no, I don't believe you. So the claim is that the percentage of Americans overweight is more than 50%. So there's a claim that's in play, right? And we want to test that claim. So when they land, they say, well, let's just look at the first several people outside the airport, because in the airport you don't know where they're from. So they go to like a, maybe not Walmart. They just drive around looking at people walking down the sidewalk, and they see they see 42 people, and out of those people they see 27 of them are obviously overweight. They don't stop and put them on a scale or anything. That would be interesting. And excuse me, I'm from Italy. I just need to... So far, that looks like it's done, right? So some people might think, why do I have to do anything else? Because what would P hat be here?
X.
Yeah, what percentage of the people they saw are overweight? What out of what? Tell me exactly.
27 out of 42.
Okay, now tell me approximately. What is that? 64%. Okay. Ish. Now, that obviously is bigger than 50%, but why is that not by itself enough evidence? Okay, one test, but there's a more important point here. How many people did they actually look at. And the claim is about how many people?
27.
The claim is about all of America, every American, right? You guys with me? So, any sample I take by itself will not be enough evidence, especially if it's a smaller sample. If they looked at 8,000 people and they got 64%, I almost don't have to do anything. That's way over 50%. Really good sample size. We had those kind of problems way back in chapter 1. And I kept telling you, we'll learn this stuff later, but when they gave it to you then, it had to be really extreme, right? Either it was, he thought it'd be 24% and it was 25%. I was like, well, that's freaking close enough, geez. Or he thought it was going to be 70 and it was actually 98. And you're like, well, that's evidence that's not. But it's such a small sample that maybe this is not enough evidence. So I have to build a way to test this claim. So the first step, and I'm going to try to introduce terminology along with bringing in old calculations that we've already done. First step is just to write your claim down. So our claim is this. Why is this not wearing a hat?
Population?
It's population. It's a claim about the population. We always test a claim about the population by getting a sample. So our p-hat later is going to actually test this claim of the population. That's why this guy's not wearing any hat. They're a little more, I don't know, hatless. So we have, if the claim is that, then if it turns out that it's wrong, the opposite looks to be possibly correct, right? Now, the outcome of any hypothesis test can't be anything with certainty, obviously, because statistics is very honest. It says, I don't care what actually comes out of this, there's always some chance I'm wrong. You kind of with me? So we already kind of know that from this. We're going to be using this for the 1 and 2 tail test. So how many tail tests do you think this is going to be? If I draw this picture, where would I want things to fall to show that this is true? I want it to be way up here. So the idea is, here's 0.5 right in the middle. I'm going to assume that that really is the population percentage. You guys kind of with me so far? Okay. So I'm going to assume that that really is it. And then what I want to do is get a sample, and if I want this to be true, if I want it to be bigger than that, I want to find a sample that's so far up here that there's no way that this could be the middle. So if that really is the true middle, and I take a sample, where should that sample percentage come out? If that really is the true percentage, it should be close to it. So there's some dividing line that says this is okay and this is too far. That's far enough to be evidence that it's not that. So if I get something that's way up there, it's more likely that the middle is higher, right? It's less likely that the middle is actually in the right place. There is a chance that the middle's in the right place. There's a chance I just happen to pick randomly larger people in this case, right? But what's more likely is that the middle's in the wrong place. It should actually be a little higher. So if this middle is in the right place and I end up here, then I just did something that's remarkably difficult to do. Because the chances of that happening are really small. It's way the hell out there, right? So what's more likely than this being in the right place is this is in the wrong place. It's actually bigger than 0.5. So how are we doing so far? So depending on what the claim is, I'm going to draw where we call this part, we call this here, well, let's see, the book calls it the critical region. I think I'll stick with that for right now. I'll tell you what I call it here in a bit. Okay, so the first little thing I got to tell you, this is what I was talking about earlier. If this is the claim, there must be some other side to this, right? So if they think it's greater than 0.5, what's the other side kind of think, or what's the opposite of this?
Less than 50% of Americans.
Be careful. Not less than. That's not the opposite. Or equal to. Exactly. Cool. So one of these two statements has got to have an equal sign in it. If neither of them do, then you haven't captured everything. They're not opposites of each other. Because true opposites together should cover everything. All right? So one of them's got to have an equal sign in it. So we give these two statements names, and we call them both hypotheses. Right? These are claims. These are hypotheses that somebody has. So we call one of them the null hypothesis, and we give it the name HO, and I don't know if you guys realize, I mean, that we call this H naught very often, but null means kind of like the zero position. So we call it HO. You're going to love this. And then the other one is the alternate hypothesis. And my old book called it HA, but I think this book, I don't know, I haven't checked this new position. Yeah, it's still H1. So we talk about the hose and we talk about the highs. Right? Just to get that out of the way right now. Well, it used to be the hose and the highs. But now it's the hose and the highs. Okay, so HO will always be the statement that has an equal sign in it. Let me say it again. HO will always be the statement between these two that has the equal sign in it. Because H1 is the thing I'm actually testing. So HO in this case will be this one. And H1 will be that one. H1 always sets this picture up. So do you see why this one's got to have the equal sign? This is going to be the extreme. This is going to be the thing telling me what's enough evidence. How far away do I have to be in which direction? Maybe. Okay. In this case, the claim happens to be H1, but the claim could be either one of these. If I would have said, I think it's at least 50%, that would have been greater equal to, it would have been HO would have been the claim. Right? So don't think the claim has to be either one of these. In this case, the claim is this one.
So, wait, so the claim can be either the null hypothesis or the alternative?
Beautiful. Exactly. What's most important is the HO always has to have the equal sign. If that's the one that happens to be the claim that was made, then the claim is HO. In this case, H1 happened to be the one that was the claim. All right. Got my first John? That's all right. I'm a math teacher. I could take about 30 more of those.
What happens after 30?
After 30, you don't want to know. I mean, that's the magic number for me, man. So don't. I know somebody's going to challenge me now. Let's do it. All right. Okay. How are we feeling so far? I mean, we haven't really done much. Yes, ma'am.
So what about the equal sign makes it so that that's what?
Because we've built the test that this guy is always how we set up that region. Mm-hmm. And that region, in order to show evidence that it's not something, it has to be far away. So H1 would be this area. HO would be this area. Okay. I can never prove that something equals something using a sample. Ever. So if I think the age of growth spawn is 26, and I take a sample and I get 26, I haven't proved a damn thing. I can't prove that it equals 26. Does that make sense? I've just taken a sample. But if I think the average age of growth spawn is 80, and I take a sample and I get 26, that's evidence that my idea was wrong. Right? So a sample can show evidence that it's something else. A sample can never show evidence, or you gotta be careful. It can never prove that it equals something. So that's why H1 is going to be the thing that sets up where my evidence has to happen.
Can it be either more than or less than, though? Can it be?
Of course, yeah. If my claim would have been fewer than half, then it would have been on that side. Okay. It would have been a one-tailed test down there. Yeah. Okay, cool. All right, so that's the first part.
Oh.
That's step 1 out of 5. Okay. So this is going to seem really long, and it really is actually long, but it's not this long, because I got to explain each step. When I took statistics, there were 8 steps my teacher had us do. So thanks, Jeff, for cutting out 3 of these steps. Total. I can bring it back. The second part, the second step. So you set up, this first part is, what the hell are you talking about? The second step is, what the hell are you going to use to talk about it? Right? So if I'm trying to use a test to prove this stuff, I have to know, do I use Z-scores or T-scores? So this whole idea about being far enough away, we've actually been talking about that this entire semester. To be unusual, you have to be far enough away. And actually, that used to be always further than 2. Now it's going to change based on my level of certainty that I want to use here. It's actually called the level of significance. We'll get to that. That just tells me where to look at in here. So these would be like the dividing line. I'd have to get a z-score from my sample that would be more than this, if that's the one, and that would be evidence that this guy is wrong and this guy is right. Okay, maybe.
That was a lot.
I know. Don't worry. I mean, the next several days we're going to be doing this only. You're like, oh, that sounds fantastic. Let me make this point right now. When I do this test, it could either reject. Oh, you gotta love it. It could either reject the hoe, or if you want to be a little less, I just wonder if my dean ever watches. You can reject the null hypothesis. In which case, if you say this guy looks like he's wrong, what does that mean you're saying about this guy?
Right.
Looks like he's right, because they're opposites, right? So if you reject the null, at the same time, that means you'll like this one too, you support the high. That's one thing that could happen, right? That's one situation. 2 statements, but they're both the same situation, right? If you say this guy's wrong, you're at the same time saying it looks like the other guy's right. So what else could happen? The other thing that could happen, and the words are very important, if you don't show this guy is wrong, that doesn't mean that you've proven this guy is right. Let me say that again. What did you say earlier about the equals? Can you prove it? So if I fail to show that this guy is wrong, I say exactly that. I don't say this guy is right. What I say is, I fail to reject the hoe. Right? That sounds like televangelist, don't you? I failed to reject. That might be a little bit too far in the pastor's.
So that's if it's.
That's
if it's.
Does anybody remember that?
Right?
Huh?
That's if it's right, or if it's.
Yeah. If I fail to reject, where does that mean I ended up here?
Wait.
Where it's
No, wait. So watch. If I get way the hell out there, does it look like it is 0.5? If I get way out there, no, it looks like it's actually bigger than 0.5, right? So that would be this situation.
Mm-hmm. Oh, okay.
That's why I call this region the rejection region. If you get into that region, you reject the hoe, right? Or the null. Can you see null? So I call this region the rejection region. Because that's a more appropriate name. If you get in there, you reject the null. You support the H1. If you don't get in there, you fail to reject the null. Which means what about H1? You fail to support the H1.
Oh.
So if you get way out there, then that sample shows evidence that the claim in this case, that H1 is correct. There's evidence that it's correct, because it's way the hell up there. Far enough away. So that's why we say we would support H1. How are we doing? So see how we say we support it. It doesn't say we proved it. Because you can never do that. But we do support it. If we don't get out there, then we fail to do either of those two things. We fail to reject the null. We fail to support the alternate. And again, this is going to take some time to kind of like filter in. Right? That's still step 1.
So then nothing happens? Or what happens? If that were to happen, what would happen?
So at what this is trying to say is, if I get to the point where I fail to reject it, then that means it looks like this was wrong.
Yeah.
But what I would normally do, especially if it got close, is I would just take another sample.
Okay.
And try again. Right? Because even if it's wrong, there's a chance that my sample doesn't show it. So I really want you guys to understand. If let me see. So there's one of these statements thinks the middle is 0.5. Is that cool? All right. And the other statement thinks, no, the picture actually looks like that, maybe. You with me? Either one of those, if the middle really is here, then that means I should get something in here. So I could get something right there, and that's not very far away. That's not going to be far away enough to show evidence. So that's why I can never say for sure that I proved anything. And right there, some of you guys are like, well, screw this shit. But what's important here is it's real life. All I can ever do is say, yeah, you got a 90% chance of coming out of the surgery okay. There's an 80% chance of rain over the next 4 years in San Diego. Let's make it more real. All right, maybe. So, of course, there's a chance I'll get it up there, and if the middle is here, there's a higher chance I'll get there than if the middle really is there. Let me say that again. If the middle really is up higher, there's a higher chance I'll get a sample there than if the middle's here. Getting way up there would be harder. That's why if I get a sample way up there, it's evidence that the middle really is up, which means that this guy would be right.
That would be a statistical significance?
Huh?
Would it be? Is that like
Yes, it would be statistically significant. This is a benchmark to show significance.
Get it. Okay.
All right, I like it. Maybe. And of course, we haven't actually done this problem yet. We've just set up what we're talking about. So the second step is, what am I allowed to use? So the second step is all about Z, T, or nothing. And of course, don't expect to have any nothing questions, really. I wouldn't do that on a test. That'd be evil. Because if you saw it, you wouldn't do it. And if you did see it, you'd be wasting time, and that would be evil. All right, so pretty much everything on the test is going to be doable. But the nothing would be if the n was less than 30, and I didn't say it was normal. Then you could legitimately say, I can't do this. Give me the next problem. Right? So on this problem, what would I have to check for this specific problem? What do I do? Yeah, no, careful. I'm in an NPQ situation, right? Mm-hmm. So what I have to check to see if it's normal enough? Beautiful. I got to check NP and NQ. And I love that you said NP and NQ. Might have been a mistake. I don't want to look at NP hat and Q hat. I only use P hat and Q hat if I don't know P. And the whole thing behind this process is we're assuming that P is 0.5. So really the whole idea behind this process is, okay, assuming that it is 50%, look what I just did. Right? I mean, that's why it's better than confidence intervals. They build it based off of what would the distribution look like if that really was the center. So I know the center going in. And then I try to show evidence that, no, there's a contradiction. It can't be that because I got so freaking far away from it, that can't be what the distribution would look like. Whereas a confidence interval builds it up around a sample mean or sample proportion. So it's automatically got flaws from the beginning. Okay, as far as being like evidence for something, confidence intervals, I could still use them. So, what's N for this problem? 42. What's P? 0.5. Beautiful. That's P hat. P is 0.5. So, of course, half of 42 is 21, and that's bigger than 5. So, that is beautiful. Thank you. That's the worst game of charades ever. Normal enough. Now remember what I said about NPQ problems? What does that have to do with that new stuff we just learned, T-scores? Anybody remember that beautiful thing about NPQ problems? Do I ever use T-scores with them? No. It's either Z or nothing. Sometimes on the test I'm nice. I actually just put Z or nothing. Don't expect that from me. I don't feel like being nice this semester. But for NPQ problems, it's either Z. In this case, I know it's Z. It's normal enough. Why won't it ever be T? Do I know sigma or S?
No.
No. So I can't even determine which one. So I always use Z, or if it's not normal enough, I don't do it and go to the next problem. Right, so that second step was really nice. Nothing new there at all. If this was not an NPQ problem, if it was a mean problem, right? Like I actually weighed people and took their average, and there's a standard deviation, then what would I check here? What's one thing I would look at to see if it's normal enough? What would I check? Sample size has to be greater than 30, or they just tell you that it's normal. Yeah. It's already known to be normal, maybe. Okay. So that's this step here. It's old stuff. Is it normal enough to do stuff? Yes. The third step is going to be setting this dude up. Yes, ma'am.
Do we have to do all of this in the
Yes.
exercise?
Sounds great, Jeff. So the third step is, so here we got what the hell are you talking about? Here you got what the hell can you use to talk about it. Then what's far enough away? And the next step after that is how far away did you get? So on this third step, we're going to set up where is that dividing line? How far do I have to get? And then the next step after that makes sense is take your sample and see how freaking far away you got. Right? So sort of like I always use the example of like a football coach needs somebody who's really fast. So he sets up a little test for all these people who want to be on his team, and he says, okay, run the 100-yard dash, and let's time you. And he's got a certain benchmark that he wants to get. So if you get past that benchmark, it's evidence that you can be on the team. Right? If you don't get past the benchmark, get the hell out of here. Right? I need fast people. Or not. I don't know. If you don't like football, maybe you didn't like that. Okay. So this one is to find the rejection region. I always have the image in my mind of this poor little guy just sitting there. You want to go out? No? Okay. But what defines the rejection region, I haven't given it to us yet. It's sort of related to confidence intervals, but they give me the other side. So instead of, I wouldn't tell you that it's 90%, I would tell you 10%. Right? So it's going to give me this it's alpha. That's the area that's in the tails. So this chart is actually set up perfectly for hypothesis tests. It gives you the numbers at the top of what's going on. In fact, I know from the beginning this is going to be how many tail? One tail. So I know which row to look at. So the minute I tell you what alpha is, you can go find the z-score. Right? So let's say if alpha was 0.01. Can you find the appropriate z-score that defines my rejection region? So I really want your patience. So I know it's a one-tail test, so I'm going to look up here where it says one tail. That's crazy. And I'm going to find 0.01. And then where's the z-score? All the way down, so it's going to be... Get back here, Jeff. 2.326. That establishes, now in the past, unusual always started at 2. And they just did that just because it was easy, and that's because most things use that. That's kind of based on a 95% confidence interval, sort of. Right? But now, it's going to be dependent on the situation. Sometimes you want to be more conservative, you're going to pull that in. Because if you're wrong, something might blow up. So you're like, I don't want to be wrong. Right? Or sometimes it doesn't really matter, or it's an insurance company, and you're trying to prove that your rate should go down. They're going to establish the criterion to be up there, because they want you to keep paying a lot. Right? All right, so it can change based on what the situation is. So for us, evidence that shows support for this starts here. Right? Here's the rejection region right there. If I get in here, I can reject the null, support
The high.
the high. Exactly.
Awesome.
Okay, how are we doing so far? And this is a lot. And we're going to go through the whole damn thing. And then we're going to do a whole problem. And then we're probably going to leave after that because I think we'll all be ready to leave. Okay. I keep reinforcing the idea that the most important steps of a hypothesis test is the third one and the fourth one. Because the third one says, here's what's going to show me evidence. And the fourth one is, what the hell, do I have enough evidence? So I know how far my sample has to get. What am I going to do now with my sample?
You're going to test it.
Going to test it. I'm going to make a what out of it? What is 2.326? It is a z-score. So I'm going to take my sample information and make a z-score out of it. Right? Yay. Because then I can compare it. If I get a z of 3, I got in there. I reject the null. Support the high. If I got a z of 1.8, I didn't make it. Too bad for me. Maybe. So this is the z-score, and the book calls this, and you can see why. The book calls this ZC for critical score. Because, of course, the book calls this the critical region. right? So don't let that little C confuse you. It's just a z-score that shows you what enough evidence is. Okay. All right, you guys like this about as much as I expected. So the fourth step in the 5-step process is to make a z-score out of your sample information. Just to remind you guys, the one thing that's new with NPQ problem is what the standard deviation is. So somebody remind me, I never write on this board here, probably because it's too far away. What's the formula for this confidence interval? P hat plus or minus Z. Good. So this, I said this at the time, that effectively is our standard deviation for when I take samples and I'm talking about percentages. That is the standard deviation. And it was built off of, remember, it started as NPQ. And then we had to do some work, and then it became that when I'm talking about pure percentages. That is my standard deviation for percentage problems. So a z-score, of course, for means, the z-score is this here, right? So the z-score is the same damn thing always. The z-score never changes. So step 4 is about your sample. So the formula I'm going to use is my percentage, and of course, what symbol does my percentage get? The percentage I got when we landed the airplane, p hat. So it's going to be my findings minus the middle, which in this case will be p, 0.5, divided by the standard deviation, which is over there. Now, the thing you got to be careful about is I had to use p hat and q hat here because for a confidence interval, do I know what p is? No, I'm trying to actually figure out an interval that catches it, right? So over here, do I know what p is?
Yes.
Yes. So I use no hats on these dudes. So notice the only place that your sample information comes in is on the 4th step. Do you see that? That's the first time we've used p hat anywhere in this whole process. We calculated it up here. Ooh, good for us. But the first time I used it anywhere in here is on the 4th step. It only gets used once. Right there. So I want to see is my percentage far enough away from the claim, what we're assuming the middle to be, to say that there's enough evidence. So then I just plug and chug. So we get 0.64 minus 0.5 divided by square root of 0.5 times 0.5, become a 5, over 42. So here's where you got to be careful about plugging it in your calculator. That's why I should have turned this dude on all the way. So when you plug this in your calculator, if you plug it all in at once, you got to put parentheses around the top, and then parenthesis there, and don't close it until you're there, unless you got the new one where the square root symbol grows, right? That's good for you. Good for you.
So if it grows, don't do it.
Yeah, because then you don't need the parentheses. You can just see that, make sure that it goes all over the whole thing. So with the old calculator, you got to be careful. So I would do like this, parentheses around the numerator, because the poor calculator has no eyeballs, not yet. That's on the TI 1000, and then semicolon and all that stuff happens. 0.64 minus 0.5 divided by the square root. It opens a parenthesis. Just don't close it until you're all the way to the end. 0.5 times 0.5 divided by 42. I got 1.81. So actually, let me just tell you this right now. Since there's already a z-score up here, I call this one z star.
Oh.
That's completely my own. Oh, you like that a lot, do you? Well, the one reason why I do that is just to differentiate it from the other z-score, but also because now I can do a nice visual for myself. 1.81. Where's it on this chart? Where's it? Oh, here. Yeah, it's like here, star. Right? That's where it fell. So did I find enough evidence? No. So when we first did that, we landed, we saw 64% of the people we looked at were overweight. And that's a lot bigger than 50%. But the sample was really small. So after we did this process, we actually find out that that's not enough evidence. Do you guys see that? I'd have to get out here to show evidence that this is not the right middle, this 0.5. I did not get far enough away. That could happen. That could totally happen if it was actually 0.5 in the middle. That's not that far away. It's not even unusual according to our old standards of unusual, is it? Where'd it go? There it is. Right? It's not even above 2. Okay. Notice one thing, there's a lot to notice, but one thing right here. If we would have chosen, so we chose here, where'd it go? What did we choose? 2.326? Notice if we would have chosen this one. So if the level of significance would have been 0.05 instead, what would have happened?
You would have passed it.
You guys see what I'm asking right now? This is kind of, I know, thrown. So we picked the one that made it 2.326. We didn't get far enough away according to that. If we made it a little less significant, this is why we call it the level of significance. That is a harder test to pass. So if you pass it, that is significant. If I decreased the significance, if I made it easier to pass, if I made alpha 0.05, I would have just had to get 1.645. Did we get that? Yeah, we have. So it would have passed if that would have been the level. So that could totally change the outcome of the test, right? So according to alpha that was given to me, or that I gave to us, that is not good enough. So what can we say right there?
No.
We didn't make it, so which one do we say?
We failed to reject
We
the hope.
failed to reject. Did we make it into the rejection region?
No.
So then we fail to reject. We fail everywhere, right? We fail to reject. We fail to support. So I've been saying ever since the beginning, where did we have to make it to show evidence that this guy was right and this guy was wrong? We had to make it in here. We had to make it out here, right? Further than this. Did we make it further than that? No. So then did we reject it? No, we failed. We didn't make it far enough. Right? We're losers. No. So let me put this up here. This is, thankfully, this is the last step. This is step number, what is it, 60? No, 5. So step number 5, you should expect this to happen. Just like confidence intervals, they have a little statement right at the end. And there's kind of an accepted way to do this. Right? I really don't care if you want to or not. You're going to do it. You're going to lose points. So, did we find evidence or not? No, we have failed. So the minute we fail everything. We have not found sufficient evidence. We have not found sufficient evidence. 2. Now let me stop right there. Here's where everybody freaks the hell out. I know you're all like, I'm freaking the hell out on every damn step so far, Jeff. But this is the part that I really want to make. Let's see if I can make it crystal clear this semester. Which one of these happened to be my claim? Which one? The HO or the H1?
H1.
H1 happened to be my claim. Therefore, I'm going to use the language that goes along with that to write my statement. We have not found sufficient evidence to support the claim. If my claim would have been HO, I would have used this language. I would have said we have not found sufficient evidence to reject the claim. You just use the language that goes along with which one of these is your claim. This is still new. I might have just sounded like I said, but it's going to sink in. We have not found sufficient evidence to support the claim that what? What was the claim?
That 50%, more than 50% of Americans
Good. So that more than 50% of Americans
are overweight.
of Americans. Because I'm saying Mexican. That more than 50% of Americans are overweight.
Well, I'm sure it's a lot higher in Mexico.
Yeah, I can't remember now. Did Mexico take over? I think they took over the top spot and they were shouting, look, come on, Americans. Eat. Get that top spot back. We'll never be top in certain other areas. Let's be top somewhere. All right. So a high wind, we're not going to be blown away. All right, so let's do this. Let me let you try, because there's a lot of guidance on this thing. I want you guys, this is not graded, this is nothing like that. Just try what you can with this problem. I'll be walking around. Call me over if you need some help. Maybe try something before you call me over.